Yay. All right, just first things first here. It's a Monday. Welcome to a Monday. This Friday, we're going to do like a calculator sort of section kind of thing. So bring any questions. In fact, I don't know, email me questions, I guess, or something like that. See if you have any that you said, I always wanted to see if I could do this on calculator. Let's do that. Otherwise, I'm going to give you kind of like a general overall thing, and then we're going to jump into these trig functions graphing them. We're good? Would that be good? Okay, we are on 4.3. There are, I'm going to just flip through it, 7 sections, I believe, in this section. So for 3, Wednesday is 4.5. Calculator section 6, 7. So maybe sometime next week is a test-ish, probably somewhere in that range. The following week here, and then when is we're in February, huh? For midterms, is that right? So we'll finish up chapter 4 beforehand. No, when is end of semester?
February 17th starts the new one.
Okay, gotcha. So okay, that gets us plenty of time. Okay, sounds good. Let's go for it here. So first things first. I have, let's do it this way here. I have a Ferris wheel sitting on a platform. We have that. Let me just give you some numbers here. It is 250 feet across. That's just the radius of it. Yeah. Okay. Let's see. What's some other stuff here? It's 14 feet off the ground. So it's right here when people load onto we'll put a little dot for the loading thing here. Let's see what some other things here. So it takes 20 minutes to complete 1 revolution. I think that's all that's needed there. So here it is, all yours. Now, real quick here, for when I was in college, upper division physics classes, those was fun. Those were fun. He had a fun professor. He was a little bit mentally off, but that's fine. So what we had to do is like, this is how off he was, right? Like your stick man is standing right here, right? And what we did, we had to throw a rock at the people on the Ferris wheel and just pretend it's like your worst enemy right there in the carriage. So as this thing is rotating, you had to figure out how fast you had to throw the rock in order to. Violent professor. There you go. He had a rock. Okay. So let's erase stick man.
Especially if you were 4 times away.
That's true. You should try and plant an explosive at the base would be able.
Is it 250 more?
250 feet.
I mean, all the other
250
people
feet, that's the diameter.
If you're not worried about collateral damage, then that's probably the most efficient course of action.
Or you can have a nuclear thing in your pocket.
Yeah,
Yeah.
that as well.
I would put the
So yeah, we've had
That person, maybe
we've had
not your enemy.
some jokes here about things.
I don't know, man. Then you won't do any math. You know, we all like math.
That's true.
All right, let's go for it. Let's see if we can model this by a graph. So first of all, think about, just maybe let's do this here initially. Think about what would 1 revolution look like. It goes up and then comes down. This is time. And this would be height. So just a rough sketch. What do you think it's gonna be with a rough sketch? And it's just gonna be 1 revolution. So person starts, the Ferris wheel just goes up and then comes back down. Cool. Okay.
The thing on the Desmos that you showed us, where it like
Close.
around the circle and it made the same.
When we were doing the sine curve, remember we were doing the sine curve? I think that's what George is talking about here. We had this, and then we had the extra little long side. We started at 0, 0, right? And for the sine curve, as this curved up, right? Sine curve went up like this, and then we reached the top. It does kind of curve like this, right? Because you're doing a circle on a plane, right? So as it stretches up, it goes slower and slower up. Then it went down, so then it went down like this. Yeah, so I think we have something like that. And then it hits 0 right when you hit this right here. It goes under. So in this one, talk to me here, see if this makes sense. Would this guy start at 14 feet already high? Is that right? And then I think, yeah, I mean, I said it's going to go up like this, right? And then come back down. And a nice curve here. And it's going to go like, it's going to go this way as well. It's going to go slowly up, right? It's going to hit a fast point when this guy's right here, right? That's when it's going up the fastest. It's almost vertically going up, right? And then it kind of curves. So if you got it like that, talk to me, see if that makes sense right here, right? Top of the curve. And then we're going to come back down. And eventually we're going to get that right there. And it's going to take us 20 minutes, slowest ride in the world there. Okay. All right. Talk to me. This is, you guys, you know the stuff already. What should we do? We need to model this equation.
So we want to write the equation?
Start writing the equation. I guess, perfect. We're gonna start writing the equation. I guess the question is, does this look like a sine curve or a cosine curve or upside down sine curve or upside down cosine curve? So sine curve goes like this, right? Starts off at 0, 0. There's my sine curve. All right, cosine curve. I'm thinking this one, it's the upside down cosine curve. Cool, okay, so we got that situated. This is cool. So I got y equals, first things first, we're gonna build this up anyway. So negative cosine of something, right? And I didn't even know what that something is. All right. Thank you, Grace, for that. Okay, anybody else? Talk to me. I hit you with the rough one here on a Monday morning. Wow. Straight out of the gate here. All right, let's see. Dylan, what is, oh, sorry, Grant, what's the maximum height?
That's a great question.
250, I think so, yeah. 250 plus 14 would get us to 264. Okay, so I'm thinking something along the line of this little middle, and then that little piece has something to do with something.
Would that be the amplitude?
I think so. You guys remember something called amplitude? Amplitude was from the, what's the middle height to the top, right? Or the middle height to the bottom. They're both the same. All right, so I think we got to figure that one out.
Or do you have 264?
Oh yeah, I'm not sure. Half of 250 or half of 264? That's the question before us. What do you guys say, group?
Well, it's the same. If you're going from the middle of the line, not the middle of the graph, then maybe you have 250.
Half of 250, okay. So that's half of 250, 125, I think, is that right? So that little piece there is 125. That's cool. We're building it. I think we're getting somewhere. So I'm going to put in can I squeeze in a 125 right into here? 125. Yes, those are the pins. I'm so sorry. Unless you left space here already. Okay, anything else? Dun, 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 dun. Totally fun. Love torturing students. I figure it's good for you. And you can go back through your notes, absolutely. Thumb back through your notes.
What if, you said the period is 20 minutes?
Period is 20 minutes, uh-huh. It's a cool thing, yeah, something about the period there. I'm gonna thumb through my notes, let's see what we have here. Go back to the beginning of 4.3 notes, and I think you have a formula for period, I believe. You guys have a formula for period.
Would it be 10 over pi?
Over 5.
Over pi?
Over
Or
pi.
might be.
Or would it be
Pi
pi
over
over 10?
Yeah, pi over 10 or 10 over pi. I don't know.
I mean, I sort of already saw the equation here, so I'm not.
Thank you for your honesty, Adrian.
Yeah.
Okay, so let's see. Formula for period is, I think it was this one right here, right? It was period, and it was equal to 2 pi divided by b, correct? I think that's what we had. Yeah, so in this one, we actually are trying to find the b value. That's our issue there, right? Because b value belongs in the equation itself. It's the multiplier to the x. And so we know that the period is 20 minutes. I think we have something like this happening. Is that right? So multiply both sides by b. 20b is equal to 2 pi. Divide by 20. And voila, I get my b value. So if we're going backwards, the whole point is to figure out what the a value is, figure out what the b value is as we do this. And da 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 da. I think we got it. Are we good there? Pi over 10? Adrian good? Grace good?
Yeah, I'm trying to see. Wait, what is the thing, the last part of the equation say? The one above the last b equals thing. Yeah.
That one? Initially, it was 20b is equal to 2 pi. And they would just divide it both sides by 20.
Okay.
Solve for b.
Yeah.
Cool. Okay, let's bring this up. And you guys talk to me. Are we done? Does that look about right?
Do we have to like
That's it.
add 14 or something like that because it's shifted up?
Oh yeah, hold on. I mean, it says it's shifted up, isn't it? It's not across the 0, 0 plane, right? Or the x-axis, or else it would have been right there. But we have to shift it up to this little middle. So now the question is, what is this middle right here?
Could you add 14 or?
I don't know.
I think you.
We're trying to get this middle, right? And the amplitude, well, the amplitude from here to here would be 125, right?
Oh.
Because it's how much down and how much up.
Did you add 132? Yeah, so you're trying to shift the middle of the,
Go ahead.
so are you
Talk to
trying
me.
to go from 0, 0 up?
To get the middle of our little wave that we're doing.
So then would that be half of 264? Well, no, because it's not half of all of it. It's from 0, 0 to the middle of the line. So it's 125 plus
Minus-
14, right?
Yeah,
Ooh,
that's what I said.
Yeah.
addition or subtraction?
Oh,
Needs to go with subtraction, but it could be totally wrong as usual.
So if Adrian's totally wrong as usual, let's go with addition.
yeah, it would be.
125 is what we have from here to the bottom of our graph, right? But then we also have this extra 14 to get us back to the 0 marker. Are we good? Absolutely. 125 plus 14.
Well,
Go ahead, Amaya, unless you have something else.
no, oh, never mind. I was just thinking of it. Could you do 264 divided by 2? Or is,
No, but that's not the same thing because 264 divided by 2 is
But
1.5
they're
plus
also
half of
divided by
14, and we
14.
have to
Okay,
add
gotcha.
125 plus the
Okay,
whole
okay,
14.
that makes sense.
Okay, we're good. Whew, that was cool. Okay, I think this is awesome because this is exactly what these trig functions allow us to do. They allow us to model behavior in the real world just by looking at how things, where the position of something would be, especially if it oscillates, goes up and down. And we have now a way to model it. That's cool. And you guys modeled it on a Monday morning first problem. This is good. Okay. Just want to make sure here, those that are very quiet, are you guys okay with all those things? And right now, before we go on, any questions, like Mr. Engineer, where'd you get the 125? Any of those questions? Or we know where each of those numbers are coming from?
So X is just T.
X is just T, in our case here, so for time. So now you guys see, hopefully also see the power of radian measurement, right? Because if this was degrees, none of this would make sense. But because radian measurement allows us to deal with real numbers, it allows us to now map time out as well. So this is so cool. So talk to me in our world. Talk to me, anything that oscillates, goes up and then comes back down and then goes up. I'm thinking like a piston in a car. That piston goes up and down very, very quickly, right? In order to have a combustible engine working here. I don't know. A number of daylight hours in the day, would that go fluctuate throughout the year, right? You have a certain amount and then you have the low point of it. Say again, Hayden? Okay. The tide would be also the same thing. It goes in, comes out, and it's different based upon the moon, right? Where the moon is, the location of the moon. A lot of stuff here. Let's see if you have a spring that goes up and down, right? That you're trying to do that with. Anybody else? Anything else? That just comes down and stays down.
Not if it's during the reign of terror.
Okay, I'm gonna go with it. If anybody has any other ones, you could just like, oh, Mr. GM, I know. That's cool too. Okay, so the only thing is we're stuck on is this little piece right here, because not everything starts at the bottom and the top. We good? And not everything starts at 0. So we have to be able to take this cosine function and just kind of scoot it to the left or to the right. Right? And that is something called phase shift. That's what we're going to get into next. This is where students sometimes get mixed up and they have to second guess all their work again. So, but you guys are going to be okay with it
I'm
though.
already doing.
Okay, let's see. Before we do that, I guess, yeah, we can jump to this.
Yeah, oh, this is where we're starting the second guess? Shoot, well. Yikes.
Man, you cannot second guess it if you wrong.
Okay, without writing stuff down, let's take a look at this. This is back to algebra 2. So we have x squared. Talk to me if this makes sense. Is that right? We have 0, 0, 1, 1, 1 squared, 1 squared, 2 squared is 4. So we have this little guy here, and that's our x squared. What we're going to build into it now is a number inside our function. And so x minus 3 squared. Which way does it go? Left or right?
I think right.
Right, yeah, the opposite way.
Yes,
Than you think it's
inside.
going to.
Yeah, inside the function itself, anytime you have a horizontal shift, it always goes the opposite way.
I don't remember exactly, but I remember that it was kind of dumb. So I'm thinking
Yeah,
that's
this is
Right, yeah.
the dumb one.
It's the dumb one. Yeah. Okay. So up to 3, the vertex then is up at 3, right? And then if we're going to go 1 to the right, 1 up, 2 to the right, 4 up. It's going to be all somewhere over here. And then it is symmetric, so we're all good to go. We're good? And so one more. X plus 1, you know what's going to happen. Goes left.
That way.
Perfect, okay. And then we have our little graph right here. Okay, so same thing here with this trig functions here. It's just going to go there. The only little problem is, you know how they come in waves, right? And so it's going to be more of how much compression you have on the wave itself, and then also how much shifting. We're good? So we're going to have to keep those two in mind. So let's jam. I think we'll be good. Okay, 5. Let's now go on to this one right here. Let's do it. Let's do it this way here. I'm going to do it 2 different ways. You tell me which one. We're going to vote on which one we like the best. We're good? And then I'll just do it that way here. So, and you have to vote for one of them. You have to like at least one of them. Or choose one.
I think we should make another option where we don't have to learn any of it.
Oh, okay.
And then we'll all choose that one.
Okay, let's go with it here. I'm going to graph. Can we graph this? Y is equal to cosine, and we're just going to specifically deal with just the phase shift only. Okay, so the easy one, just to get us started here. So first of all, we learned from algebra 2 that the stuff inside actually goes backwards, right? And so when we do this here, we try to, if possible, we try to take a look at this little number here. Let me do my way first, and then we'll do it the book way first. So first thing is, remember, we do have this little a here, right, for amplitude. We do have this little b value here as a multiplier, right? And this one now is called the c value right here. So phase shift, I'll just call PS, is just going to be negative c divided by b. How come the negative? Good, yeah, inside the formula itself, it's going to be opposite, and I think we're good to go. This one's the easy one, of course, so negative pi over 2 divided by 1. Are we good there? And we get ourselves a negative pi over 2. Okay, so we have a phase shift that goes a negative pi over 2. So we got ourselves left. Pi over 2, are we good there? Cool, okay. So I think you guys can graph this one here. So normally we look at amplitude first, right? Amplitude and period, that's what we do, and reflection. If we can do those 3 all at once, then our phase shift and our vertical shift just happens on the next graph and we're done. That's it's a 2-step approach usually. Okay, this is cosine. A value is 1, correct? Period is 2 pi, no changes there. Do we have a reflection, yes or no? No, okay. So we have an ordinary cosine function that looks like this.
Wait, I'm forgetting, how do you know if there's reflection?
The A has to be a negative. So the question is, how do you know if there's a reflection on your hands? A value in front of your trig function is negative. Okay, so let's jam with it here. So again, this is not the final graph. So we are going to just put dots. This is cosine, so it's going to go up to 1, down to -1. Then my dots come in as that one, that one, that one. Okay, So what we're gonna do is we're gonna take this guy, and we're gonna go to the left pi over 2. So all these dots, we're just gonna translate them back pi over 2. And so in this case, talk to me here. Let me change my, hey, that's no fun. There it is, better. Okay, talk to me here if this makes sense. We're gonna go here. We good? That little red dot became that little red dot because we were shifting everything pi over 2. So everything is shift backwards because we're going off to the left. So that means pi over 2 now shifts to the 0, 0. Pi goes back to pi over 2. 3 pi over 2 goes back to pi. And 2 pi now is at 3 pi over 2. Are we good? Sweet, I think we're done. So now notice the cosine curve. Cosine curve goes like this. And voila, like that, looks very nice.
So would you keep drawing it out to 2 pi? Because that's how long? Oh, never mind. I
How
understand.
fun. No, so good question, Maya. So on your homework, sometimes what you guys will have just to graph one complete cycle. And this would be actually one complete cycle. Sometimes in the homework, it'll tell you to graph from here to here. So from 0 to 2 pi. So on this one, I just graphed one complete cycle. If it did tell you to graph from 0 to 2 pi, then yeah, you would be erasing some things and you'd be going from there.
Yeah, so you would, even though you're moving it over, you would take that little section out that's negative and keep drawing it out to 2 pi.
So in this case, you know it starts repeating itself. So you know at least it's going to come down to the 0, 0 again. Okay, are we good there? A little bit more complicated. Ready? All right, exercise 7. Not by much, just a little bit here. Y is equal to 4 sine 2x minus 3 pi over 2. Okay, so let's jam with it. And you guys, please ask me questions if you have them, okay? I don't want it to be confused, especially when like, where did 3 come from? And then you start throwing your book across the table at home and stuff. That's not good, okay? You might as well just ask the questions here. Okay, first things first is, let's graph this here. So amplitude. Amplitude is? 4, okay? When we get to the phase shift, we'll get to it here, but period. And I can put in, for you guys real quick here, I can put in the formulas for it, right? Let's put in the formulas for it. So amplitude is the absolute value of A. So we don't care if it's negative or positive for amplitude. We just want to know how high it's going to go, how low it goes from the middle. So in this case, it's 4. We handle the reflection a little bit later on. Period is 2 pi divided by B. We're good. In this case, it is 2 pi divided by 2. Are we good there? And voila, I get a period of pi. Next is reflection. Reflection is a no, correct? Are we good there? Okay, so that's what we're going to graph first, but let's get to phase shift, PS. And it's going to go like this. It's going to go with negative C divided by B.
3 pi over 2 over 2.
Negative, right? Yeah, negative 3 pi over 2 divided by 2. Yep.
Wait, wouldn't it be negative 3 pi over 2?
I go with that. I said it, just didn't write it down.
Yeah.
Okay, negatives go away.
I just canceled out.
Becomes 2 over 1. And how about a 3 pi over 2 multiplied by what, 1/2? Since this guy spins around, takes the reciprocal of it. Are we good there? And then we've got ourselves 3 pi over 4 is what we have. Okay. How about phase shift here is a right. 3 pi over 4. Are we good there? Okay, talk to me here. I see a couple of people that I think they just saw a ghost.
Wait, can you explain how you got from 3 pi over 2 over 2?
Over 1,
to 3 pi over
This
4
one right
again?
here? Absolutely. And so can I just do some other numbers here, just so you guys have it here? So this will be 2/3 divided by 5, right? If we have something like that from algebra. And what we do is we just say to ourselves, that really just means this. That means 2/3 being divided by 5 over 1. In this case, then it turns into 2/3 multiplying the reciprocal. There's that. So what we do is we keep the top fraction exactly the same. But what we do is we take the reciprocal of our denominator. Then at that point, then we multiply things out and we're good. There. So for this one, then it was keep the 3 pi over 2 exactly the same. Take the reciprocal of 2 over 1, which is 1 over 2, and then we get to that. We good there? Thank you so much, Grace, for the question. That's cool. Okay, I think we're good. Time we have. I think we're ready. Let me go to this guy. So we're gonna graph this piece first, right? Just put dots for this piece here. So let's see if we do this all in one step here. Amplitude of 4, period of pi, and no reflection. And it's a sine curve. So over here, I'm gonna go only to pi. So I'm gonna divide these guys up into pi over 2. This would be pi over 4. This would be 3 pi over 4. And I got myself 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm gonna go from 5 to 5, knowing that I'm gonna stop at 4 anyways. Okay, it's a sine curve, right? So my dots begin with 0, 0, pi over 4, 4, 0, 0, 3 pi over 4, negative 4, and tell me if you guys agree. All right, let me change the color. Okay, are we good with the dots? Are we good with the dots? Let's go with, now the change here. Phase shift means we're gonna go 3 pi over 4 to the right. Man, that's a lot. Okay, so let's see what's gonna happen here. In fact, I'm gonna say this here. I'm gonna say, go back to it here. And I'm going to say, let's graph it from the way the book does it here. Oh, let's go 0. Here's my graphing window for you guys right there. Still want to go from 0 to pi. Okay, so I still want this window right here. So I'm shifting my graph more so, right, than my, okay, so 3 pi over 4. Okay, so that means this dot here at 0, 0, that dot is actually going to go all the way to here. Are we good? That makes sense?
It's moving that way.
To the right, because it was a, let's check here, it was a negative. Okay. So this, yeah, this dot here went all the way to here. Good there? So that means this dot is going to go all the way to here. Okay, based upon that, can we move our imaginary dots over? So Grant, I think we had a dot over here at negative pi over 4. Where was our imaginary dot? 0, 4, or negative 4? I give you 1/3 guess of getting it right. If this was going like this, there's the black dots that go like this right here, right? So if we went backwards, where would the dot at negative pi over 4 be?
Oh,
I'll give you a hint, it has a negative in the name.
like you're going backwards 3 pi over 4?
I'm gonna go backwards. Yeah, so the black dots, I'm just graphing these guys backwards over here, yeah. So I'm thinking somewhere over here. Are we good there? Just a small dot. I'm thinking negative 4, is that right? It would have been a negative 4 if it graphed backwards. So we're gonna move this guy 3 pi over 4, which is all the way over here. Oh, good. So we're kind of moving things that are not in our domain into our domain. So that means once I see this little pattern here, everybody okay with me putting a 0 over here, right? Because technically, let's graph this guy. This guy would have went like this right here, right? So that dot there now becomes this dot here. This dot became that dot, and then that top dot should come in as a dot right here. Okay, I think we're good. How about this? Boom. Wait, what? That's just a cosine curve by itself, isn't it?
Okay, I'm a little confused as to what you did, but what I did was bumped everything, like how you did the first dot, how you bumped it to the right, and then I just bumped the rest of them to the right, but then extended it back to the 0. Is that what I was supposed to do?
Yep, absolutely. So you got these imaginary dots over here that are outside your domain, and you're still putting them in based upon the pattern that you're getting. Okay, we run out of time. Not done yet with this fun stuff. So we'll come back to this problem. We'll do it a different way, and then we get to vote which way we want to keep on doing these here. Let's stop for now.
Sorry.